Hello, class. Today we're going to go over 6.2, apply properties of rational exponents. So first we're going to review properties of exponents, which you learned about in Algebra 1. And then we're going to apply them using exponents that have fractions. So for the first property, if you have two exponents you're multiplying together with the same base, you're going to add the exponents. So if you have a to the m times a to the n, you would add the m and the n together. So looking at the example we have here, 12 to the 1/8 times 12 to the 1/6. They both have a 12 for their base, so I'll have a 12 for my base. We would add those exponents, 1/8 plus 5/6. To do this, we do need common denominators. So you have to think of what denominator would work. And I would let's do 24. So I'd multiply top and bottom by 4, and then top and bottom by 3. So you get 12 to the 3 24ths plus 20 24ths. So you get 12 to the 23 24ths as your answer. For the next one, if you have a to the m to the n power, you take those two exponents and you multiply them together. So you multiply the m and the n together. So for 3 to the 3/5 to the 5th power, we're going to multiply those exponents together. So we'd have 3 to the 3/5 times 5. Put that 5 over 1, and the 5's cancel out. So you get 3 to the 3rd power, which you can simplify to 27. The next property, if you have a times b to the power of n, so m, so you have two numbers or two variables being multiplied together and the whole thing is a power, you can distribute that power to each item on that inside. So like for 8 times 17 to the 4th power, we would distribute the 4th. So it's 8 to the 4th times 17 to the 4th power. Now, the next property is if you have a negative exponent, you can make it positive by moving it to the opposite floor of a fraction. Okay. So for 5 to the negative 3rd power, if we want to make that a positive, we need to put it over 1. So 1 over 5 cubed. So notice that the 3 became positive, and this becomes 1 over 125. Now when you're dividing exponents with the same base, you subtract. So if we have 10 divided by 10 to the 2/5, so notice these are both the same base. They both have 10. That top 10 is to the first power. So when we go to subtract this, it'll be 10 to the 1 minus 2/5. Now I would make common denominators, so I would change this to 10 to the 5/5 minus 2/5. So it's 10 to the 3/5. And then for this last property, they're just saying if you have a fraction and it's all to one exponent, you can distribute the exponent into the top and the bottom. So over here on the right-hand side, we have 56 to the 1/4 over 7 to the 1/4, and that whole thing is to the power of m. So we can actually distribute that power. So it'd be 56 to the 1/4 times m, so m over 4, over 7 to the 1/4 times m would be 7 to the m over 4. All right, so that's it for our review of the properties of rational exponents. For the properties of radicals, if you have two numbers on the inside of a radical, they're being multiplied together, you can split it up. So it'd be the radical of the first number times the radical of the second number. Same goes for division. You could divvy up that division, right? Split it off. So for this example here, part A, we have the cubed root of 125 times the cubed root of 8. Now for this one, you could use the property and combine them, but I don't understand why you would do that because the cubed root of 125 is 5, and the cubed root of 8 is 2. So you would just do 5 times 2, which is 10. For part B, we have the 5th root of 96 divided by the 5th root of 3. So we could combine these, 96 divided by 3, all over under that 5th root. Well, 3 goes into 96 32 times. So I get the 5th root of 32, and our final answer would be 2. Okay, in this next example, we're going to write the expressions in simplest form. So for the first one, we have the cubed root of 104. So I would make a factor tree. We're going to try and figure out if there's a cubed root that 104 is divisible by. So I know I can divide it by 2, and I get 52, 2 and 26, 2 and 13. So I do have 3 sets of 2. So 2 cubed times 13 equals 104. So I'm going to write this as the cubed root of 2 times 2 times 2 is 8 times 13. And then we can break it up. The cubed root of 8 times the cubed root of 13. The cubed root of 8 is 2. So I get 2 times the cubed root of 13 as my final answer. And that's because I don't know what the cubed root of 13 is without a calculator. Now for part B, the fourth root of 10 times the fourth root of 3. Let's do the fourth root of 30. Not sure if that's going to help us much, but let's see. If I make a factor tree, we don't have anything really that we can break this down into and then simplify using the fourth root. So we would just leave it like that. Okay, so for variables under a radical, if you have the nth root of x and n is an odd number, then your answer is just x. If n is an even, then it's the absolute value of x. Okay. Now, for this next example, we're just simplifying these problems. So for that first expression, we do have the fourth root of 625 times z to the 12th. So we're going to try and find numbers that we can take the fourth root of and values we can take the fourth root of to take out of there. So first, for 625, let's see if there's anything that works for that. Okay, so for 625, let's see here. Well, is it divisible by 5? Let's see. It is. So we have 5 and 125. And then I know 125 is 5 times 25. And then it breaks up to 5 and 5. So I do end up getting 4 5s, which tells me the fourth root of 625 is 5. Okay, so I'm just going to leave that as it is. And then for z to the 12th power, so if we're finding the fourth root of that, you could think of it as how many sets of z to the 4th do you have in there? Well, you have 3 sets, right? Z to the 4th times z to the 4th times z to the 4th. So when we break that down, the 4th and the root will cancel out each time. Okay. So what ends up happening here is the fourth root of 625 becomes a 5. And then the fourth root of z to the 4th is z. Fourth root of z to the 4th is z. Fourth root of z to the 4th is z. So you end up getting 5z cubed. Now for part B, we have 32 m to the 5th n to the 30th to the 1/5 power. So what I would actually do here is I would distribute the 1/5. So 32 to the 1/5, m to the 5th to the 1/5, and n to the 30th to the 1/5. So then 32 to the 1/5 is the same as the 5th root of 32. So the 5th root of 32 is 2. For m to the 5th to 1/5, you would multiply the 5 times the 1/5, so that becomes m to the 1st power. And we would do the same thing for n to the 30th to the 1/5. 30 times 1/5 would be n to the 30 divided by 5. So you end up getting 2 times m times n to the 6th power as your final answer. For part C, we have the 6th root of r to the 6th over s to the 18th. So you can either leave it as the 6th root, or what I like to do is change it to an exponent. So I would have r to the 6th over s to the 18th, and that's all. Instead of 6th root, it'd be to the power of 1/6. I like doing this because I can distribute the power, so I get r to the 6th times 1/6 over s to the 18th to the 1/6. So then all we have to do is multiply those exponents together, right? So r to the 6 times 1/6 is just r to the 1st. And then s to the 18th power times 1/6 would be s to the 18 over 6. So our final answer is r over s cubed. So I think that is a little easier than sticking with the root like we did in part A. Okay, in this next example, we're going to write each expression in simplest form, and we want no radicals in the denominator, so no roots in the denominator. So for part A, I have the cubed root of all of this. So cubed root of, I'm going to leave the 6 because there's nothing we can do with that. X to the 4th, I can break up into x to the 3rd times x. So the reason I took out an x is so that it would be something I could find the cubed root of. Y to the 9th, I can find the cubed root of because it's divisible by 3. For z to the 14th, if we did z to the 12th times z squared, because z to the 12th is divisible by 3. So then I'm just going to go through this, and anything I can take the cubed root of, I'm going to do. So I know I can take the cubed root of x cubed, and that becomes an x. The next thing I can take the cubed root of is y to the 9th. The cubed root of y to the 9th is y cubed. Okay, because you take the 9 and you divide it by the 3. The cubed root of z to the 12th is z to the 4th, because 12 divided by 3 is 4. Everything else has to stay under the root. So the 6, the x, and the z squared stay underneath, under the cubed root, and then that's your final answer. For part B, we have the 7th root of p to the 8th over q to the 5th. I am going to rewrite this as the 7th root of p to the 8th over the 7th root of q to the 5th. Now for p to the 8th, I can break that up. 7th root of p to the 7th times p. So then when I simplify that, 7th root of p to the 7th becomes p on the outside. I still have the 7th root of that extra p. Now on the bottom, we have this 5th root of q to the, the 7th root of q to the 5th power. We can't take the 7th root of q to the 5th. So since we can't have a root in the bottom, we need to find a way to get rid of it. To do that, I'm going to think to myself, how many more q's would I need so that I could cancel out the 7th root? Well, if the root's a 7, I need 7 q's underneath there. Well, I only have 5 right now. So to fix that, I'm going to multiply by the 7th root of q squared, because q to the 5th times q squared will give us q to the 7th. Whatever we do to the bottom, we do have to do the top as well. So when I multiply this out, I have that p on the outside still. And then under the 7th root, I'm going to have the p and the q squared. Now on the bottom, it becomes the 7th root of q to the 7th. So that we can simplify now to get rid of the root, which means on top we still have the p times 7th root of pq squared, but the bottom becomes a q. And that is your final answer now that the root is out of the bottom. Okay, so this is our last set of problems here, and we're going to simplify them. So for the first problem, we have 18 times the cubed root of u minus 11 times the cubed root of u. Since they both have a cubed root of u, they're like terms. So you can just take those coefficients and subtract them. 18 of these cubed roots minus 11 of these cubed roots gives you 7 of the cubed roots of u. And that's it. Now for the next problem, 15a to the fourth b to the 2/3 plus 8a to the fourth b to the 2/3. Notice they both have a to the fourth and b to the 2/3. Since those are both the same, and the only thing that's different is the coefficients, we can combine these. They're like terms. So if we have 15 of these terms and we're adding 8 more of them, we have a total of 23 of the a to the fourth times b to the 2/3. And that's all you would need to do. Okay, for part C, we have 10 times the fourth root of 5s to the 7th minus s times the fourth root of 80s cubed. So for the first part, 10 times the fourth root of 5 s to the 7th, I'm going to break up into s to the 4th times s cubed minus s times the fourth root of 80 can be, let's see, is 80 divisible by 5? 5 goes into 80 16 times. So I'm going to do 5 times 16. The reason I'm doing that is because the 16 is also a fourth root. We can find the fourth root of 16. That's what we want. We want to be able to simplify that. Now the s cubed we can't break up anymore. Okay, so now let's go back to the beginning. We have that 10. For the fourth root, I can't find the fourth root of 5, but the fourth root of s to the fourth is just s, so I'm going to put one s on the outside. And then what's underneath that fourth root is 5s cubed. Minus, on this other part, we have an s on the outside. Underneath the root, I don't know the fourth root of 5, but I know the fourth root of 16 is 2. So I'm going to do times 2. So under that fourth root, we are still going to have the 5 and the s cubed. So I end up having 10s times the fourth root of 5s cubed minus 2s times the fourth root of 5s cubed. So notice, both of these terms have the same parts here, s to the fourth times 5s cubed. That means they are, again, like terms. So I'm going to do 10 of them minus 2 of them to get a total of 8s times the fourth root of 5s cubed. And that's our final answer for that problem. That is also it for notes today. If you have any questions, be sure and contact your teacher.